Hey friends, today we're working on solving exponential equations when we can't make the bases the same. If you remember in the last lesson, one of the questions, I think it was 2 to the exponent x equals 7, we couldn't make the bases the same. So I said, what can we do? Well, the only thing we can do at that point was to graph it. Okay, today what we're going to learn how to do is solve that algebraically. Okay, how we're going to solve these things algebraically is logarithms. Okay, so logarithms are going to be a little weird until you get used to them. But going back to grade 10, when you first learned what sine, cosine, and tangent were, those were weird too. Logarithms, a little bit the same, but you'll get the hang of it. Please go grab your formula sheet, hit pause, keep your formula sheet in front of you when you're doing logarithms. All right? So we'll be in logs for the next 3 or 4 lessons or so. We'll get a good hang of them. Okay, I'm going to hide my face, and we are going to start solving some exponential equations when we can't make the bases the same. And to do that, we're going to use logarithms. Okay, so what do we do when we can't make the bases the same? So what we're going to do is we're going to find that this thing here called a logarithm is going to be very helpful. At the beginning of the unit, what we figured out is that a logarithm is an inverse of an exponential. Okay? What I want you to think of is an inverse. An inverse is undoing something. It undoes something. You've been doing inverses since you were little guys, but you just never called it that. Adding to and then subtracting to from another undoes each other. Those are inverses. Multiplying by 5 and then dividing by 5. Those are inverses. They undo each other. Sine and sine inverse undo each other. Those are inverses. So you've been doing inverses for years and years. You just never maybe knew that you were doing inverses, right? So what I want you to think is an inverse undoes something. Okay, that's going to be the key here. It's going to help us solve for that unknown exponent. Okay? So the other way we can also, it's going to be helpful for us to think of it is that when we're taking an inverse, that's us taking our x and our y values, and we're going to switch them. Okay? So here we go. Now, I'm not going to prove this law to you, okay? This little rule here. You're just going to blindly trust me that I'm telling you the truth, which I am on this one, okay? If we were face to face and we had more time, I would spend a lot of time showing to you where it comes from. But for now, you're going to trust me, okay? Here's what this is telling us, is if you look at this, it's saying, here's how we're going to go from an unknown exponent, right? We're not able to solve for that exponent. And what we're going to do is we're going to turn this into a logarithm, okay? And by turning it into a logarithm, look where that exponent ends up going. The exponent ends up being the number or the side that we're trying to solve for. Okay, so that's going to be really, really useful. Okay, now this here is on my formula sheet right there. Okay, that's my, we are taking a huge shortcut here, right? It feels, again, a bit like magic because I'm not showing you all the steps in between, but for now it's good enough. Okay, so what I want you to notice here is the exponent. Do you see the exponent? Comes down here, right? And now do you see we've still got base A. So I'm going to say the base stays the same. And you notice what happens with the x and the y values? The x and the y values actually stop and they switch, they change positions. So the bases of both of our log and our exponential functions are the same. We see the exponent becomes equal to the left-hand side or to the whatever we're trying to solve for. So I'm just going to say it becomes equal to a number, right? And the x and the y values just switched. So my little expression that I like to use is base stays the same and the other two parts switch. Okay, base stays the same, the other two parts switch. Now, this again is a little bit strange because I'm skipping a bunch of steps that if I was in class and I had more time, I'd be showing to you. But it's once you get the hang of it, it's pretty straightforward. Okay, let's look at example number 1. Okay, example number 1 says, let's convert these things from exponential to log functions. So right now, I've got a base of 2 right there. Okay, I've got an exponent of y, and it's equal to some number x. So my expression is base stays the same. Base stays the same. So I say to myself, what's my base? 2. So it's going to be log base, and it's important that you're writing that 2 as a subscript. It's a base. Log base 2. And now I'm going to say the other parts switch. The other parts switch. So that means the y is going to go where the x was. So now we've solved for that unknown exponent, and the x goes where the y was. So what we've got there is something that says y is equal to log base 2 of x. What we've effectively done is isolated for an unknown exponent. We've changed from an exponential to a logarithm. Okay? Later on, I'll show you how to graph these things and what they look like. But for now, our job is simply just to switch forms. Once we switch forms, then we've got a lot of tools in our belt. Okay, the next one, B. 7 to the exponent y is equal to x. So I say to myself, my base is 7. My base is 7. So it's log base 7, and the other two parts switch. So I'm isolating for my exponent, and the x goes where the 7 was. Y is equal to log base 7 of x. Love it. Okay, next one. Base stays the same. So log base b, the other two parts switch. So I'm solving for the unknown exponent. Boom, there it is. Okay, so again, every time what I want you really noticing when we're switching to a logarithm is that unknown exponent is now being isolated. We're able to find out whatever that number is. Okay, that's the whole key. Now, if I can go one way in math, I have to be able to go the other, right? That's one of the beautiful things about math. Math is closed like that. We can go one way, then we can go the other. So if I can convert to a logarithm, I should be able to go the other way around and convert to an exponential. Well, the rule stays the same. Base stays the same. So I'm log base 2. So 2 to the exponent x. The other two switch. Do you see the x and the y switch positions? Okay, next one. Base stays the same. So my base is 6. My other two parts switch. So my x goes where my y was. Just like that. Okay, and last one here. You know, again, it's all variables, no big deal, nothing changes. Base stays the same, so my base is a, and my other two parts switch. So I'm going to go log base a to the exponent c is equal to b. Just like that. Okay, so again, every time my little expression is going to stay the same. My base stays the same, my other two parts switch. Okay, again, like I said at the beginning, it's a bit of a strange rule. Okay, it'll take you a little bit to get used to this, but again, the nice thing is in 30-2, we leave that right on our formula sheet. Okay, so here we go. So the reason why we're doing this, or we're learning this, is so that we can solve for these unknown exponents. Okay, so here we go. We can solve. There's only one variable. It says let's solve for y. So the first thing I try to do is I say, can I make the bases the same? I can't. I don't know what 10 to the power of is going to give me 81. So I can't make the bases the same. If I can't make the bases the same, Now I turn it into an exponential or a logarithm. Well, since I'm already in exponential form, I'm going to turn it into a logarithm, right? So base stays the same, log base 10, the other two parts switch. The y goes where the 81 was, and the 81 goes inside my logarithm. That's called the argument of the logarithm. So we have y is equal to log base 10 of 81. Now, you can actually stick that in your calculator. When you go to put that in your calculator, you don't need to put in the base 10. If you remember from one of our earlier lessons, that's called a common logarithm. So you don't need to worry about putting in the base 10. Your calculator assumes that that's base 10. So if I put that in my calculator, most of you are just going to put it in. It's going to look just like this. Okay. Now, some of you before spring break, we talked about you have a log base button, okay, that you can use, which is very, very handy. So if I wanted to get that in my calculator, that would be approximately that. Okay. But really, I'm super happy if you leave it there. That's an exact value. Okay, next one. Same idea. It's an exponential function, unknown exponent. I can't make the bases the same, or at least not very easily. So I'm going to switch to a logarithm. Base stays the same. The other two parts switch. Now, this is a base of 5. It's not a common logarithm. So those of you who have the log base button are able to put that in your calculator. But the rest of us without the log base button, what you're going to do is use something called change of base. Here's how change of base works. It's on my formula sheet. But really what you're going to do is you need to make this into base 10. And you're using this law called change of base. So it goes like this. I'm going to split my log up like this. Okay, I'm going to go a log divided by a log. And then what's in my argument right there, maybe I'll change that to green. What's in my argument goes to my numerator, and what's in my base goes to the argument of my denominator, just like that. And now all of us, regardless if we have that log base button or not, can all put that in our calculator, and we should get something that is approximately 1.32. Okay, so change of base is a handy way of turning a logarithm into a common logarithm. Okay, again, people of TI-84s and the gray Casio, you have a log base button. Okay, those of us with TI-83s or white Casios, we don't. We have to use change of base. Okay, C. Unknown exponent, can't make the bases the same. Let's turn it into a logarithm. So base stays the same, log base 6, the other two parts switch. There it is. Now, again, that's the perfect answer. I'm happy with that. But if for some reason the question says, what is that equal to the nearest 10th or 100th, I'm going to do change of base. So again, notice what was in the argument right there goes to the numerator, and the base goes to the argument of the denominator. And I can stick that in my calculator, and that's going to be about 1.38. Again, we're truncating here, so I don't like that. I actually prefer this as an answer, but you're going to be asked to round to the nearest 10th at some point, or 100th or something. Okay, let's try a few more. Once we get the hang of this, just like yesterday, once you get the hang of converting forms, there's not a lot to this. Okay, a couple of small things that come up along the way, especially on diplomas, they'll throw something like this at us, where, again, just like yesterday, if you remember, there's a coefficient. The wrong thing, don't do this. This is no bueno. Do not do that and multiply. You can't do that, right? You can't multiply a coefficient by the base. So what we're going to do is I'm going to say to myself, well, if I can't multiply by the 3, I've got to get rid of it. Well, the inverse of multiplying is dividing. I'm going to get rid of it. So let's get rid of it. I'm going to divide both sides by 3. 8 divided by 3. Now I say to myself, 8 divided by 3, that's ugly. It's a fraction. No, it's fine. Don't worry about it. Okay? Not all numbers in life are pretty little looking integers. It's okay to be a fraction, a rational number. Okay? Then I say to myself, can I make the bases the same? Nope. So I have to turn it into a logarithm. So base stays the same. My base right now is the 4. And the other two parts switch. So the x plus 1, I'm now able to isolate 4. And my argument of my logarithm is 8/3. Okay? And I'm almost done. I say, I got to get x by itself. So the inverse of adding 1 is subtracting 1. So I'm going to subtract 1 from both sides. And there it is. Okay? Now again, I'm going to put that in my calculator. And I'm going to round to, I don't know, probably the nearest 100th. Sounds like an okay thing. And I get a negative number. I don't panic about that. It's okay to have a negative value. Okay, I can't have a negative argument in my logarithm, if you remember that from graphing. But right now I'm solving for an exponent, and exponents can be negative numbers. Okay? So again, the moral of the story is if you have that coefficient flying around, I want you to divide, get rid of it. So on the next one here, the first thing I'm going to do is divide both sides by 2. Again, changing how it looks, not what it's equal to. Boom. Okay, now I'm going to turn this into a logarithm because I've got an unknown exponent. I can't make the bases the same. So my base of my logarithm is the same as the base of my exponential. The other two parts switch. So my argument is 6. X over 4. Well, I got x divided by 4. The inverse of division is multiplication. So when I multiply, I'm going to multiply that 4. I'm going to put it out front. I'm going to make it a coefficient. And now again, I can just slip that thing into my calculator. And I'll round to the nearest 100th again. I get x is approximately equal to 6.52. Okay. Now the handy thing on both of these questions, again, any of these questions, is you could graph and solve these right off the bat and get the answer, or I can check every one of my answers. I take that value and I stick it back up in there for x. If the left-hand side is equal to the right-hand side, guess what? You did it right. If the left-hand side does not equal the right-hand side, you done did screw up. Go back and fix it. Okay? So when you're doing an assessment, a test, anything, when you're done, go back and check. You can tell me or your teacher if you did everything right by checking your work. Okay, here, I'm going to divide both sides by 10. Get rid of that coefficient. Now, the base is a half. Some of you don't like fractions. Okay, I'll change it to 0.5. Whatever. It's a little bit easier to put 0.5 in your calculator when you're using logarithms as well. But doesn't matter. Okay, base can't make the bases the same, so I'm going to switch to a logarithm. So again, by doing that, I'm just changing how it looks, not what it's equal to. There it is. And multiply both sides by 6. So 6 times log base 0.5 of 12. 6. Sometimes the longest part of the question is just getting it in your calculator, especially if you're using the change of base formula every time. Okay, I'm going to get a nasty approximation of a negative number here, negative 21.51. Okay, so there it is. So again, it's a bit strange because these laws of logs, you know, they feel a bit like magic when you're first learning them. Again, if we were face to face, I'd be spending, almost an entire class having you do a bit of an investigation and figure out where these laws are coming from. But for now, you're just going to trust that you're using the formula on your formula sheet to switch forms, and that's helping us solve for these unknown exponents. Okay, almost there already. Okay, so this part here at the bottom says, how do we put it in our calculator if it's not log base 10? Okay, in class, I would have let you struggle with this a bit more, but in the lesson here, I just showed it to you right off the bat to make it easy. This is on my formula sheet. So change of base tells me when I don't have base 10, I can use change of base like that. So my base is b here is not 10. I'm going to use change of base to make everything a common logarithm. Okay. Now on your formula sheet, if you're looking at it, I'm going to write it beside. You actually see that on your formula sheet, they put a base of a there. Because you know what you can do? You can make that base anything you want. For us in 30-2, it's going to be easiest to always make that base 10, because that's what our calculators handle. Okay. Later on, if you take 30-1, we're going to make these bases different numbers. And when we go on to calculus, we're going to find out that this base, we're going to change to a very, very, very special number that looks like this, also known as E. Okay, so that's the reason why the A is there, because the A lets us put any base we want. But my friends, in 30-2, we're going to make that base always 10. Okay, now even if you have a fancy calculator that does change of base for you, I need you practicing using change of base as well. Okay, so next one. Solve for the variable in each of the following. Oh, it's a log. My unknown right there is inside a log. So I say to myself, my unknown's inside a log. Guess what I'm going to do? Switch to an exponential. Unknowns inside a logarithm, switch to an exponential. How do I do that? Same expression. Base stays the same. So base 5 and the other two parts, switch. Guess what? That's 125. Okay, so again, my thought, the question that I'm asking myself is, where's my unknown? My unknown on the next one is inside a logarithm. If my unknown's inside a logarithm, I'm going to change how it looks to an exponential. How do I do that? Base stays the same. The other two parts, switch. Okay. 3 to the 4 should be 81. And divide both sides by 3, that's 27. Okay. So every time, what I'm asking myself is I'm saying, where's that unknown? My unknown's inside a logarithm, switch to an exponential. So base stays the same. The other two parts, switch. Okay. Now from here, 2 to the power 4 is 16. I want to solve for x, so I'm going to take the square root of both sides. All right, I'm going to take the square root of both sides. And I need you to remember, when I take a square root of a number, I get a positive and a negative. Okay, so when I take a square root of a number, I'm going to get a positive and a negative value. Okay, most of the time in 30-2, this ain't going to happen. Okay, it's probably a little beyond 30-2, right? It's more of a 30-1, but it's a good thing to remember that. When I take the square root of a number, I get a positive and a negative. The primary and secondary roots, if you want to be a huge nerd like me, which you don't. I heard you through the video say, no, I don't. Okay, so here's your summary, my friends. Exponential and logarithmic functions are inverses of each other. That means they undo each other. Okay? If we have an unknown exponent and we can't make the bases equal, then we must use logarithms. To switch between exponential and log forms, again, my little expression, we keep the bases the same and switch the other two, or as I've typed right there, just look at my formula sheet. Okay. I've heard over the years a ton of expressions for how teachers show their kids to switch between these two forms, whatever works for you. Okay. Our calculators only use base 10. Now, to change the base, we must use the change of base formula. Now, some of you have this fancy log button on your calculator. I still want y'all to know how change of base works. It's important, okay? Pops up on diplomas, pops up on my test, hint, hint, nudge, nudge, wink, wink. Okay, you can never take the log of a negative number. So if you tried to put something like this in your calculator, it's going to say no can do. It's going to probably say error or non-real answer, something. I don't even know anymore. I don't use a calculator that much. Probably says non-real. Okay. And this one here, not too important for today, but I want you to start looking at this thing and I want you to start recognizing it. It says log base A of A is equal to what? Well, if I'm not sure, I'm just going to plug in a number that's convenient. Easiest number to always plug in on a logarithm is 10 because that's what our calculators handle. I stick that in my calculator, guess what it's going to say? 1. Why does it say that? Because using change of base, I'm really, if I can write, what I'm really doing is going log A divided by log A. So this will always equal 1. So when the base and the argument are the same, it will always equal 1. Okay, so friends, remember, unknown exponent, try to make the bases the same. If you can't make the bases the same, turn it into a logarithm. If I have an unknown inside a logarithm, I'm going to turn it into an exponential. Keep my formula sheet in front of me and always check my work by graphing things or subbing my answer back in. Okay, guys, that was a little bit trickier than yesterday, but we'll get there. Email me if you have questions. Hope you're all doing well at home. Take care. Talk to you soon. Bye-bye.